All right. Hello,
Yeah,
everybody.
right.
Hello.
It is now December 29th. It's a Wednesday. So now we are on a stretch where we're just going over answers. Now that we've covered all the questions. And today we are going to be covering answers for day 12 and 13. So let's first start by reviewing a bit of what day 12's question was.
Yeah.
I'll share my screen for that one. See if
I like day 12.
Yeah. Find day 12. Ah. Okay. What is this one on my screen? Can you guys see my screen already, or which one?
No.
All right.
It doesn't say you're sharing at all.
Let me see where my screen might be. Hold on again. Technical difficulties again. It's got to be on here somewhere. There it is. All right, day 12.
Okay.
So passage pathing. So this is one where we're given some connections, right? Like start and A and start and B and A and C and so on. And these connections can be represented or looked at as kind of a graph or just a chart, right? With things connected together. However, as they're connected together, there are some rules. One of the rules is that there's a difference between the uppercase and the lowercase letters. And so uppercase letters, you can go back in as many times as you'd like, but the lowercase letters, I think you can only enter them once, right?
Yeah, for part one, only one time.
Yeah. So to visit the small caves at most once, visit big caves any number of times. So that was kind of the rules. And your objective at the end of it
To find the full
how
number
many
of
paths to this cave system are there that visit the small caves at most once? So how many are there? So yeah, so how'd you guys approach this one?
Again, I used graph traversal. I tried with depth first. I tried to go start with start and go until I reach end. But I had a problem to switch the path after the start. So I realized the depth first is not the best approach for this one. So I switched to breadth first with more loss on the space. So I have more space now being used, but with breadth first, I was able to get the solution. So every time I will take my current cave and take its neighbors, push them into my queue. And to my queue, I will not only push my neighbor, but I will push the neighbor as well as the path that led me to that neighbor. So if I'm currently on start, my neighbor is B. To my queue, I will push B, and also I will push start B. So as a pass.
So the whole path.
Yeah. So next time when I reach that neighbor, I can see from which path that neighbor is coming.
That sounds similar to how I solved it.
Yeah. I ended up using a breadth search as well. Depth first is kind of is better if you actually have a particular endpoint in mind. Things like, most efficient way to get to the end, or the fastest way to get to the end, or shortest way to get to the end. But when you have this kind of question where it's like, how many possibilities are there, then yeah, breadth first seems to be a lot easier. I also think, I believe I used a queue system as well. The traditional breadth search is a queue and another list of visited items, especially like this one where you can only visit certain things once. But all right, let's get into the code then. Who wants to start today's?
You want to go first, Farouk?
Okay.
Do you go back to Python for this one?
Not yet. It's hard times, man. You need a stronger sword.
Yeah.
maybe on the easier days.
Not as brave as Alex doing everything in a new language.
I wanted to do it in Python too after I was done with JavaScript, but didn't have enough energy. Like, yeah.
You already got the answer. Move on.
So also, I don't have a file path for this one. I'm just using input as a string separated by new line. So first of all, I'm creating an adjacency list. TXT file. So this is my starting input, right? With connections. So I have a new function here, which is adjacency list that should create me an object with all my caves as a properties and with all the caves that my current cave can go to or its neighbors as an array of strings. So I'm creating this one first. And after I create this, I'm starting with start, my breadth first search. So, oh, excuse me. I will take my start and take my first neighbor and push my queue. I will push A because the neighbor is A, and my path, so far my path is start, and I'll take next one, B. My path is still start. I push it to my queue, and that's it with start here. And take the next item from my queue, for example, A, and my current item is A, and my path is start, right? And A has C, B, and as its neighbors. So to my queue, I will push C, which is A's neighbor or cave can go to, and to my path, I pass start and A, because it is start and A, and next one is C. And next one is A can go to B. So my queue will have next item B as start and A, and also end as start and A. Start and A. Because all the C, B, end are going from the same path. I'm going to start A first, and going to C, start A, then B, start A, and then end. So on. Okay. After I create in my adjacency list, basically just changing the data structure here from array into this form. So after I get my adjacency list or graph, I will call my find paths function here for part one. I think I'm calling it in here. So I'm passing my adjacency list, I'm passing my starting point, and I'm passing my paths array as a third parameter. Oh, start. It's not even being used yet. So collection has all the paths which start with start and end on end. So it's basically a collection of the correct paths or available paths. So my queue, I will start, the first parameter is start, and when I'm on start, I don't have any history or I do not have any paths yet because I'm just starting. So I will start my traversing here, and as long as my queue is not empty, I will take the first element from my queue and get the current cave from my queue. For example, let's say this is my queue and this is my first now. After I shift, I get this one. And here I will get my cave, current cave. For example, here my current cave is start, which is the property of the element in the array. And my current path is the value of that object. After I get my cave and path, I will check if my current cave is a big cave, I will add it to my path. If it's a small cave, if it's a small cave, I will check if it has been, I will get my current path, split it by comma. For example, here it's start A, I'll get my start and A into an array and check if my path includes the current cave. includes this if I have visited a small cave before, and if so, if it's a start, I will just push my start. If it's another cave, I will push my path, and I will add my current cave to that path. If it has been visited, we will not add it to the path. And if it, I think I will pop it from my path. But
if it's a lowercase item.
yeah, item. I think it's not even necessary.
You do need the lowercase condition there, so that you don't visit lowercase rooms 2 times.
So
at least line 126.
How about the popping stuff? I think I don't need the popping, right? Yeah, because it is from my previous logic when I was using depth first search. Okay. But here, yeah, I can just skip. If I have visited my small cave before, I can just skip and go on.
Where else are you checking for the small cave? Are you checking for it somewhere else?
Yeah, here. So if it's a big cave, I will add it to my path, right? Okay. If it's not a big cave, I'll come to the next one and I check if path array means my history of caves that I have visited. I will turn them into an array and check if that array includes my current cave. If it doesn't include, I will add it. Yeah, otherwise just continue. And if my last item in my history is end, I will add the path to my collection. Otherwise, I will add each neighbor of the current cave into my queue as a current cave and the history until that cave. Yeah. This is it, part 1.
Okay.
Any questions?
Yeah.
Oh, that's pretty good.
Shall I share mine?
Sure.
All right, let me make sure I got the right day open. All right, can you see my screen?
Yep.
All right, here's my part 1. This is my just code page. I created a separate file for my code with comments, just so you can see both ones. So this is what it all looks like. Let me skip to the comments to help explain it. So, like I almost always do, I decided to import my file because it's quite a long one. It wasn't that bad. It was only 22 lines for the input, but I imported it anyways. And then I split it on each line. And then I also split each element by the hyphens. So my final input is going to look like this. It'll be an array of arrays with 2 elements inside, the left room and the right room, I guess. Because each row only showed 1 connection. So now all I need to do is I'm going to initialize a counter variable. So I called it num paths because I'm trying to find the number of paths. So I thought that was a logical name. And then I have a recursive function here to check, pretty much like Farouk did, to check all of the paths connected to the current room and to see if they are valid paths that I can actually move into those rooms. And so this function accepts the current room, so the current room that I'm inspecting or that I'm in right now, and an array of the previously visited paths or the previously visited rooms. All right, and so the first time that I call this function, I'm going to call it like this, find next, and I'm going to pass in start, because that's the room that I want to start in, and an empty array, because I've not yet visited any rooms. So let's check out my function then. So the first thing I do in here is I'm starting a for loop. So I'm going to loop through my entire array. So my input array like this, I'm going to loop through each element to see or to try to find ones that include the room I'm looking for. Like here, I would do something for number 6. I would keep going and do something for number 11 and do something here anytime that I find the room I'm interested in. So the first thing I have to do then is to get the 2 elements, since each row or each entry into my main array has 2 entries in it. I'm going to put the first element as A and my second one as B, just short variables. There's no need for them to be long. I could have named them left and right. That would also be the same. Anyways, the first element is A, the second one is B. And now I have a few conditional checks. So if neither room matches my current room that I'm looking for, then I'm just going to skip that row and I'm going to continue to go on to the next row. Next, I have to check if a room is lowercase. And if it is lowercase, I need to see if I've already visited it, because I can only go to a lowercase room 1 time. So I have my check here. I'm checking if the value or if the string is the same as that string converted to lowercase. So if this is true, that means that that is a lowercase room. So I want to check, is it already in my path? If it is already there, then I'm going to continue. So I'm going to skip the rest of this iteration. Next, I'm making a temporary copy of my paths. So the paths array that I passed in here, I'm gonna make a copy of it. Next, I'm gonna check my connection rooms. So first, I'm gonna check if one of the rooms is end. So that means one of my rooms is the current room I'm looking for, and it's connected to the end. That means my path can end. I can finish the path right here. So we're gonna finish it here. And I'm gonna increment my counter because that means I've found a successful path. And I'm gonna just add that also to my path so that I don't really need this. I mostly just used it for console logging to make sure I was getting all of the paths correct. But for actual logic, it's no longer necessary. Next, I'm going to see if I'm not at the end. So that means the room connected to the current room, at least in this row. So for example, here I'm at start and the next room is not the end. So that means I can move there. It's interesting. So I'm going to check it out. I'm going to add my current room to my paths array, or to my temporary paths array. And then I'm going to, why did I make a temporary paths array? I don't think I need it.
It's empty at first.
Yeah. Yeah, I think that's a remnant of how I had my code before. I don't think I need it. I think I can just use paths.
What is current already?
Current is the current room that I'm like inspecting.
Oh, okay.
So I'm checking it before I add it to the paths array, because I don't know, is it going to lead to a dead end? Is it even a valid room? Because I have all of my checks at the beginning of the function here to see if it's a valid room.
Mm-hmm.
So if it is, yeah, I think I can get rid of my paths copy here. And I think I can just, maybe not, no, because then I'm just going to be creating a reference to my paths array. So it's never really going to get updated. So I think I do need the copy here. So anyways, I want to create a new array. I want to pass a new array, not just a reference to my old one. So I'm going to add that current room because it's an interesting room. I can go there. It has a path. I'm going to add that to my copy of the array. And then I have to check. So which room is my current one? Is my current room on the left side or is it on the right side? So I just needed a quick conditional here to check which one I'm going to go into for the next one. And then I'm going to go into that next room. I'm going to run my function, find next. I'm going to pass in the connected room and my copy of my paths array with the current room added in. There's a lot of talking. I feel like I just kind of blabbered on and just rambled on. Do you understand?
Yeah.
I'm following too.
Yeah.
So why do you have A and B?
Just because I have 2 different elements. So here's A and here's B in each row.
Okay. So you're visiting both at the same time?
No, I'm only going to be visiting one. So I'm only going to call my function for one of them.
Oh, okay, so you're using that you're using that list in both directions. You're using that list to go from start to B as well as B to start.
Well, here I'm checking which one is my start. So which one did I actually start on?
Right. So if you visited and the current is A, the room that you're in is A, then you're going to go to B. If the room that you're in is B, you're going to go to A, but you're going to do calculations for both of them regardless, right?
Eventually, yeah. So for example, in my input here, like on row 6, I have start is on the left. So that's my current element. So I want to go into this element. So I'm going to run my find next function, pass it in this room. But down here on row 11, like start is on the right side here.
Mhm.
So but I still want to check out this room. So I'm going to call my function checking out this room instead. So here I would pass in B and here I pass in A.
Well, you pass in both, but your code chooses one at the end, right?
Yeah.
You're checking both. And then you're checking to see if either one is end. And then at the end of it, you choose one or the other depending on what is considered current from your paths. Yeah, because you just go over the list and you're picking out anywhere along the line where that is contained, right?
Anywhere, any row that has that element, yeah.
Right, on the left or the right, because you have that contains
Yeah.
Condition or includes condition. Okay, interesting, cool.
All right.
Very good, very good. I will share mine. I could figure out which one of my 10 windows I have is the one. I think it's this one. Now let me open this up in an easier, more familiar format for you guys. So my approach was somewhat similar, but I actually did mine, I would say what I call DFS-ish, not complete DFS, but kind of, because I did actually want the ends, because I wanted the ends, I just wanted to know how many were the ends. So I could have done it breadth first, but I instead opted to do it depth first. But anyways, my inputs I have up in the top instead of reading it from a file, which means that that's unnecessary. But anyways, and then I create a lookup structure like I did before. Now, when I first did this, I actually was thinking, oh, maybe I should create a linked list and actually kind of mimic a graph. That's a little, ambitious, especially since Rust already contains a linked list. But I tried creating my own, and it was horrendous. I do not know Rust well enough to actually pull this off. So that was my failed attempt. Instead, I decided to just create a lookup table. The lookup table essentially contains what I call names and edges, but essentially all it means is the ones on the left side are what I consider names, the ones on the right side are what I consider edges. But they're comprised of both. So this is how I kind of dealt with the same issue that we just talked about with Scott, and making sure that each path goes two ways. So when it says, for example, HR and DA, you can go from HR to DA, but you can also go from DA to HR, right? As long as you didn't actually visit the lowercase rooms yet. And so my way of getting around that is just to create two data structures, one going from HR to DA and one going from DA to HR. So from graph to name, or from name to name to edge, or edge to name. So I have two versions of that. Anyways, so that gets created, and then I traverse it, and my traversal essentially just get the path. So I have a visited that I kind of keep track of, because I know that I can't visit, for example, lowercase is more than once. So I keep this so I can keep track of that and make sure that I don't visit a lowercase one again. I have a new path, which keeps track of where I've been for the sake of reconstituting the entire history of where I've been in the past, including the uppercase ones, so that I can, at the end, print out the path. Because what this will end up being is a recursive function. So I calls visit, goes into a new room, see where I can go. If any of my neighbors are lowercase, I see if the lowercase ones, have been somewhere I've been to yet, and I go visit them if I haven't visited them yet. And then if it's an end, then I know I found a way to get to the end, and I just take my entire history of paths, wrap them together with commas between them, and then stick it in a vector for now, and then go on to the next one. So so I would say it's kind of depth first search, because I go ahead and recurse before I recurse to see where I would go, before I check my neighbors to see which neighbors are valid neighbors, and then put them in a queue and then take one up the queue at a time. I thought I had done this with the queue, but I guess I didn't, because I did do it DFS, or DFS-ish. I don't actually have a stack, so there you go. Anyway, that was my approach to it. So it's kind of, I guess, a little mixture of Farouk's and Scott's.
So you are also keeping track, like history for each cave, right? Or each path?
Yeah, so I have two pieces of history. One is the visited, just so that I know which lowercase ones I visited, so I don't visit lowercase ones again. And then I have another one called new path, which just keeps track of where I have been, including the uppercase ones. And this is new path, I could call history, but basically where I've been in the past. And then new visited should be lowercase visited, to make it a little bit more clear in terms of variable names. I've kind of abused the word new. When I didn't know what to call it, I just put in new. The new path was so far my history of where this current path has been in my recursive journey, where I've been so far in my recursive journey. And then new visited is all the lowercase ones I've been through, so that I don't revisit lowercase ones.
Because when I tried with DFS, I didn't keep track of its history, so I was getting lost. Like I didn't know how to switch between the caves.
Oh, yeah. It can get a little daunting. Fortunately, I don't think we ever have here uppercase to uppercase.
That'd just be infinite if you did.
Because if we did, then mine probably wouldn't work.
It would be infinite, really, because you could just keep.
Yeah, I think ours too. Yeah.
So this is the kind of puzzle where that he had to carefully make sure that didn't happen.
Right, and so that's why I kind of consider this DFS-ish, not really true DFS, but close enough. But because of that, at least a bone toss to us and not having two uppercase ones, it was like, oh, it still works.
There'd be no answer if there were two uppercase ones.
That's true. Or you'd have to introduce a new rule.
A, B, finish, A, B, finish, A, B, a million times.
Like, I mean, they could have added like one extra rule, like you can't go back to the room you came from, for example, that you immediately came from. I mean, but then you can have three uppercase. You could just go around in a diamond.
In a triangle.
But at least for the purposes of this, it worked out all right.
All right.
Is there this many graph-related problems each year, or
this year has a lot, I think.
I mean, it's dependent on approach, because a lot of these graph problems can also be solved by just like what I did, creating in lookup tables. You don't have to actually create the true like vectors and edges kind of deal. Even vectors and edges can be modeled with linked lists. It can be modeled with references on, and stored in vectors. It can, but in terms of, I think we do another one later on. I think maybe day 15, where we do trying to find a path, and each path has a weight.
Yeah, that was 15.
Yeah. I mean, that could also be approached as either a really complex matrix, or I did a heat map and it didn't quite work, but it actually worked enough to get me a false positive, which is kind of amusing to me. Or you could do it with a graph. And so it's just an option, I think, rather than, this is a graph problem. I think, it's an option that you can always consider.
All right. So we go on to part 2?
Even though I actually call mine graph when it's not really a graph. But anyways.
But we are kind of simulating it at least, right?
Yeah.
Mine is
Yeah,
not
that's true.
also, yeah, mine also is not a graph, but yeah.
Yeah. All right, let's go to part B.
Part 2 was pretty much the exact same, except now we have, instead of only visiting or lowercase rooms once, you can visit a single lowercase room 2 times.
Yeah. Just one.
Yeah, so only one lowercase room you can choose to visit twice during a path. But
I think
it
a lot
creates a lot more
of people made a mistake on that one. Like they did not read it carefully, so they thought like they can visit any
any lowercase twice, right?
Yeah. No, you can only visit one lowercase cave 2 times.
But if for every journey, that could be a different lowercase room. So
Yeah. Like in this example one, actually, in this example, we have C and B. So you could visit C 2 times, or you could visit B 2 times. And the rest of your path will change up too, because they have a lot of different options on how to get there.
Right.
yeah,
So in this example.
and you can go back and forth a lot too, like this guy.
Basically wasting time.
How many, I think for that sample, originally when you could visit a lowercase room only one time, there were only 10 paths. Is that right? Or 17 paths, maybe?
10.
10 paths. And now there's 103 paths.
Oh no, this is
possibility.
slightly larger one.
Oh, this is a bigger one?
Yeah, so small one was 10 and it's 36 in the new one.
Okay. It's still quite a big difference. Gives you a lot more possibilities.
Yeah. So for mine in the code, I didn't really change much. I mean, what you have to do is you have to at least, when I'm populating my visited, I have to say, do I have to keep track of the one that I've assigned, that special room that I can visit twice. I have to keep track of which one that is each time I go through. And then when I populate my visited, I just have to make sure, maybe I'll ignore it once. And so let's see, where does it get changed? Oh, so here. So as I look through its neighbors, if it's a room that I have already visited, which means new visitor, remember, is only the lowercase ones. So if it's a lowercase one that I have already visited, then I'm going to do something different, right? And the new different thing is, well, I have a new one pass room, which I added it to the end of this. I was like, how do I pass this back and forth? Didn't create a global. I just created another. Oh my God, this is like the longest argument here. So I added another variable for that. So as I recurse and it calls itself, it gets passed along as to like, hey, this is that one special room. But I create that one special room and I go visit it anyways. And say, okay, I've allowed the one time this one room to pass, and then it never will happen again. But as long as it's not the start, because start's lowercase. And let's see. Oh, and so far one pass is blank. No, we have not assigned a one pass yet. So as long as those 2 conditions are met, it's not start and we haven't assigned a one pass yet, then I'll go ahead and populate the one pass and then keep going with what I would normally do as if I've never visited the room. And that's the only difference change I made.
Okay.
That allows that one time to go into one lowercase room again.
Cool.
All
Can I
right.
share mine?
Yep.
Yeah.
Mine is only a slight bit of extra code. All right, let me see. All right, yeah, so here's my part 2 for it. The only thing new is up here at the beginning of my find next recursive function, before I start looping through the different paths in the input, I'm adding in a check to just check to make sure we don't have more than 2 of the same element or the same lowercase element. So first, now I actually have a couple checks. Let me go to my one with comments. So my first new line here is I'm checking if the current one is the start. So if I'm just starting my search, I don't want to go back to start a second time, and start is lowercase. So I do have to be careful about that. I had to add in an extra condition, don't go back to start. Because my next check here, I'm checking if the current element, so the room that I'm inspecting to see if I want to go into there, I'm checking if it is lowercase and if it's already in my current path. So if I've already visited it once, then I'm going to do a little extra check. So I want to make sure that I can visit it once and I can visit it twice, but I want to make sure that I haven't already visited a lowercase room twice. So I'm going to do a quick check here. I'm created a check array, which is the result of filtering my paths and only keeping the lowercase elements, so the lowercase rooms. And now in order to get rid of the duplicates there, I created a set from there. So a check is just an array of all the lowercase rooms that I visited, and it might have a duplicate. Whereas check set, it will not have any duplicates, just the lowercase rooms I visited. So I just have to check the length of those. If check is longer than my check set, that means it already has a duplicate lowercase room in there. So I'm going to return because this path fails. This path will just end right here because I've gone and now, I'm trying to go into a lowercase room for the second time, but I've already visited a room for the second time. So I'm just going to cut the path off right there and not continue the rest of my function.
Otherwise, you will continue and add one more small cave to the path, right?
Otherwise, I will continue. And down here, I still have my other checks to make sure that I'm even, is this even a viable path? Is it even connected to the room I'm looking at? And yeah, the rest of it's completely the same as my part 1 code. Just added these extra lines. Yeah.
Nice.
That's all.
Cool.
Yeah, I think that's a nice condition check with the set here. Like it's a quick way to check if it's a duplicate or no, right?
Yeah, I love using sets to get rid of duplicates like that.
Okay.
Nice new feature. I forget, when were sets added? Was that just a few years ago?
Okay, I will share my part 2. Mine has quite a bit to it, but idea is same. Basically, like I also have a condition, and since I'm keeping the track of my history for each cave I'm visiting, when I have to check if I have visited any small cave once or twice, it starts here. So first, from my paths, I will remove my big caves first from my history. And after I remove my big caves, I will count how many times each small cave have been visited. So I have a frequency counter, and first I have filtered here my past history. And if it's not big cave, and if it's not equal to start and end, I will add this to my frequency counter. So I have a property as a cave. Cave has a property in my object, and the count is the value of that property. So I will get my values from my frequency counter, and if there is a no to, if none of the caves have been visited twice, or my history doesn't include the current cave, I will add it to my history. Otherwise, I will go on as before. So my condition is here. Yeah. I also probably set would be a better approach here, but I used this counting basically to check how many times I have visited the small cave. Yeah, that's about it regarding the update for part 2.
Small change from part 1.
Mhm.
Yeah. And I didn't have this line, and it took me a while, not this one. So when I wrote it first time, it was like this. I was checking if my history includes any small cave visited twice, and it wasn't giving the exact answer. It was less, because I might have a cave which is visited twice, and I still might visit another small cave. You know, here, if I have visited any small cave twice, it just will not visit any small cave anymore. So, yeah, this one, and that's it. It took me 7 minutes and 54.
Oh,
7.54 minutes.
why do you have a? Oh, okay. Wow.
And my result was actually 130,000 around.
Oh, okay, bigger than mine. My final answer was like 98,000 something.
What, so 8 minutes to run?
Huh?
It took what, so 8 minutes to run?
No, 1 second. All right. Glad we all solved it. Should we go on to day 13?
Let's do it.
Day 13 or 15?
13.
13, 1, 3.
That's an interesting one, day 13.
Day 13.
I like the calendar, how it's like a map of our journey in the submarine.
Yeah.
You can see like on like day 5, you see like the hydrothermal vents.
Yeah, right there.
And then, yeah, and then for like day 9 through 15-ish, you can see us going through the cave system.
Yeah.
And I think if you refresh the page, every time the patterns on the water are different. Like all the different symbols in the middle of the water change locations every time you refresh.
There you go.
Yeah, it's kind of cool. So it looks like it's moving. Looks like you got some water flowing.
Cool.
Oh, every time you refresh?
Yeah, all the little dots, all the little blue dots on the page.
Yeah, the water randomizes.
Somewhere else. Nice little touch.
Yeah. All right, sorry to distract from day 13.
All right, so day 13. Volcanically active part of the cave. So you have an infrared thermal camera system, and you got a bunch of, what are these, ranges?
No, those are locations.
Oh, these are locations.
Values
Right.
of dots on the paper.
Right,
So
so you take those, you put them on the paper, and then you follow the fold instructions.
Yeah, you fold your paper. Yeah, and eventually you're gonna get a code that you have to input.
Right.
But for part 1, all we had to do was we have to fold it one time, only the first fold, and count how many dots are visible. And remember, if dots overlap, then you're gonna lose a dot because it's only gonna be visible now as 1.
Right.
So yeah, that's part 1, is just how many dots after the first fold.
Okay.
Want me to go first?
Sure.
All right, I think my code's a little bit messy at the beginning of this one. I wasn't super proud of how I started it. But let's get on to it. Yeah, so this one was quite a bit of code. It's a little bit longer than day 12. So here's all my code, 71 lines. Let's get to it. So here's my file with comments to make it easier. So first I import my file. I'll show you my input. My input looked like this. It is 839 lines of dot locations. And then what, about 11 lines of folds. So the first thing I do, I import that and I split it by line. So my input now looks like this, where I have an array of elements. These are all just strings. So 610, 014 for all of my dots. And then I have an empty element in the middle here that I can safely ignore for now because of what I'm going to do next. And then I have my fold instructions. So I'm going to separate that into more useful data. I'm first going to create an array for my dots. So for my dots, I'm just going to filter this input array to check if the first element is a number. So I'm just going to see, can I parse int it? And is that greater than -1? That means yes, it starts with a number. It doesn't start with a fold. And then I'm going to split that on the comma. So now my dots array is going to look like this, an array of arrays of strings. So these are currently strings. I probably should have mapped them to a number right there, but it's not important at the moment. Next, I'm going to get my folds array. And this one, actually, I probably don't even need for part 1, but I knew that I would need it for part 2. So I tried to anticipate a little bit. I knew that since the input gave us a whole list of folds, part 2 is probably going to make us do all of the folds. So I got my folds array. That's going to end up looking like this, with just an array of strings with all the instructions. And now I don't know why, I'm not proud of how I went through this, but it ended up working and looking nicely for my console logs at least. I created an array for my paper. So this is going to be my grid pretty much. It'll show all of the dots and hashes to essentially be just like the example from the website. So next, I need to populate my paper. I need to add all of the elements to it. Right now, it's just a blank sheet of paper. I don't like that. So in order to do this, I'm going to keep track of the maximum X value and the maximum Y value from my dots array. So I want to find how wide is this paper and how tall is this paper, how many rows and how many columns. So I'm just going to loop through my dots array. And I'm going to capture those values. If it is the biggest X value, I'm going to save it to my max X. If it's the biggest Y value, I'm going to save it to my max Y. So now that I have the maximum height and the maximum width for my paper, I can populate it. So I'm going to create my grid here with just nested loops. So first of all, I'm going to go down on each row of my grid. And I'm going to add a new array element. And then I'm going to go through. For each row I go down, I'm adding an array element, and then I'm going to populate that array element with just dots for now. So now I just got a giant grid of dots, of periods. Now I'm going to go through and actually put my data onto my paper. So I went through my dots array again, and so for every location that I actually have a dot, I'm going to get its X value and its Y value, and I'm going to put it on the paper as a hash mark or the number symbol. All right, so that was all just set up. That took me a long time just to set up my paper. Now my paper is finally a grid. I'm sure there were more efficient ways I could have done that, but I wanted to focus more on the rest of the logic. So once I got it looking how I wanted, I just ignored it and didn't go back to clean it up. So now I have two functions here. I have my fold Y for, so this means I'm going to fold on a Y line. So I'm going to fold it vertically. And I also have my fold X. And these are very similar functions. but they are different enough that I needed to create two different functions for them. Because when I fold on Y's, well, let me explain how I'm going through it. So I had to make an assumption here that turned out to be correct, I guess, is that we're always folding the paper in half. You're never going to fold like just a tiny bit on the bottom up or a tiny bit on the top down. You're always folding paper in half each time. So I'm going to set my new variable here, new Y, as 0. So that means I'm going to start at the top row for my new Y. And now this is the important part here. I'm going to loop through backwards through my paper. So I'm going to loop backwards through all the rows on my paper, starting from the bottom. So essentially, I'm folding my paper up. I'm going to fold the bottom part up onto the top. So now for each row, starting from the bottom, I'm just going to search from the left to the right for any hashtag elements. So if there is a hashtag element, I'm going to put that onto the top of my paper. So my new Y, I'm starting at the top with my new Y, and I'm starting at the bottom with Y. And anytime there's a location like YX on the bottom, I'm going to add that to the top if it's a dot. And then I'm going to increment my new Y as my Y decrements. So they're always going to start from the top and bottom, and they'll meet in the middle at the fold line. And then I'm just going to cut my paper in half. So I'm getting rid of now everything below the fold line. So now my paper has just got cut in half. And for my fold X, so if I'm folding on a vertical line, it's going to be essentially the same thing, except I have to switch around my logic because now my rows and columns are all mixed around. So now I'm going to start from the left side at my new X, and I'm going to loop through each row starting on the right side. So I'm going to start on the right side and loop to my fold line. And if I encounter an element or a dot, then I'm going to put that dot in that same row, but on the corresponding new X value. So here, X is starting from the end of the paper, and new X is starting at the beginning of the paper. And we're just going to go put all of the elements where they go corresponding, and then we'll meet in the middle at the fold line. And then, because I'm folding horizontally, I actually have to loop through my paper now to cut every row at the fold line. So now I'm getting rid of the right half with my paper. So I've folded the right half onto the left half, and I get rid of the right half. All right, so those are my main functions. Now all I really have to do is just loop through. Actually, for part one, I don't even need a loop because we're only doing the very first fold, but I created this one kind of in anticipation of the next round. And I believe, was there an example where it folded multiple times? Yeah, I think in one of the examples it folded multiple times. So I think that's what I did my tests with, why I settled on a loop, but I ended up only looping one time. So here I'm going to capture my fold line. So this is where I actually parse through my folds array. I'm going to capture how many elements or where am I going to fold it? So is it the X or Y value where I'm going to fold it? And then I'm going to see, am I folding it on the X axis? If so, then I'm going to do my fold X and pass in my fold line. So if not, then I'm folding on the Y axis. So I'm going to call fold Y with my fold line. And so now at the very end here, if I console log my paper is going to be a lot smaller, and it's going to have only the remaining dots. So all I need to do now is count how many dots are on my paper. So I use the reduce function here. So first I flatten my array. I do paper.flat to get it all on the one level. I don't want sub arrays anymore. And I'm going to reduce that. So I'm going to loop through every time I find a hashtag mark. I'm going to increase my counter pretty much. And at the end, my final number of dots will be in my number of dots, num dots variable. So I can console log that. Questions, concerns?
No questions here.
All right,
Here.
it's okay, easy enough to understand?
I think so.
Okay, me next.
Sure.
Right. So yeah, back to Python.
Oh, switch it in.
Nice.
I like how you hop back and forth.
I had solved it earlier in earlier attempts. So actually, my approach to this problem was simple. If I remember correctly, let me share the router element of code. So I prefer to work with the coordinates instead of the actual map in this problem because I have a list of the coordinates in the plane, and every time when I fold the paper in the y or x-axis, my coordinates will change accordingly to that number in the y or x-axis. For example, if I fold it y-wise, here, let's say this is the last one here. If I fold it, that will end up here, right? So it was maybe 10 or 7. I found the pattern, like there is a certain pattern. So for this to come here, it is the number or certain line which I folded and minus the length or the previous coordinate. So every time when there is a fold in y or x axis, I'm updating my coordinates. So the duplicate ones will disappear by default because I'm storing them in a dictionary, remember? So every time I fold, I will just update my coordinates according to that pattern. So at the end of the foldings, I will get the number of the keys in that dictionary and return that key. So I didn't worry about the map or the paper.
It's your own makeshift set, huh?
Yeah.
That was part 2.
What was that, Alex? Sorry.
It's like you created your own version of set using dictionaries.
Similar.
Yeah,
So,
you're trying to get rid of duplicate values, right?
yeah. So first I'm separating my instructions from my input. Now it's a separate file. Here's my sample input. So we have the coordinates first, and after a new line or space new line, we have the instructions. So first I'm getting the instructions from my input into the instructions array. And I am removing the instructions from my input here. And then I'm reversing my instructions. Because here it will take, I think, from the last one. Yeah, since I'm starting at the end, it will put the last ones first into my array, but we have to start from the top. So I will reverse it. And from here, I will start my loop. For the first part, it's just once. So we have the range 0, 1, and I will get my first, this is instruction 1. So which axis? Is it the x-axis or y-axis? So this one defines that axis. And second one is the number. So how many times, or what's the length of the fold, or what's the line which we are going to fold. So I will get those ones first. And if my axis is y, I will start looping through my input, and I'll get my input 1, like it should be y2. I think both of them are changing. I get my input 1 and input 2. If my input 2 is larger than my current instruction fold line, I will update my input accordingly. So let's say this is Y, my X will not be affected. When I fold Y axis, my X will not be affected, and my Y will be determined in this fashion. So I will subtract the instruction from my current coordinate, and the result of that subtraction will be subtracted from the instructed line. This will determine the new coordinate after the fold. Same thing for the X. If we are folding XYs, my Y coordinate will not be updated, but my X will be updated in the similar pattern here to Y. So then I'll get my keys from dictionary, the coordinates, and yeah, return the length of that input or that keys. This is for part 2. For part 1, we don't need this. This was all the change I had to do for part 2, this part and this one. Any questions?
No.
Looks good.
I don't know, this one just came, yeah, approach.
Cool.
So, okay, yeah, part 2 later.
All right, I'll do mine. Let's see, where is mine? It's on this window. Pretty much what you guys got done. I take my inputs and I create my vector of vectors of stuff. So I have input coordinates and input folds. Input coordinates are these, and the input folds are the folds. And I go through some processing to make sure that for the folds, which I detect just to see if the first character is an F. But for the folds, split by space, splits by equals, narrow down until I can get the number and the letter, just like you guys had done, or yeah, you guys have done, and then I store those as, you know, an X fold at whatever value, which gets turned into a number. Otherwise, I split it by the commas because they're just regular coordinates, and I store them as a vector of 2 numbers, 32-bit integer numbers on the left and the right. So everything should be numbers except for the axis letters. At that point, we're only interested in the first one, so I'm going to just only get the first ones. Oh, looks like it's a tuple. Tuples. Oh, I did create a tuple. Look at that. Instead of creating a vector, I use a tuple. I don't know why. Maybe I just decided to. It's pretty much doesn't really make that much of a difference in this code, but so I get the fold direction, X and the Y, and the fold at, you know, at what axis do I want to fold this? And then I use the fold to fold, yay! Which is basically a reduce in Rust. Depending on whether it's on the x-axis or the y-axis or the x-axis, just like you guys had, do a little bit of math if I need to. And after I do my math, I push it back into my my accumulator, my reducer. And if it doesn't exist, then I insert it. So make sure that I only have 1 copy of everything. Yeah, I mean, the key line is probably just this one. Just making sure that whatever Y I'm looking at, if I'm folding it at the Y, whatever I'm looking at, I just make sure that this thing is on one side of the Y, because I gotta get rid of the other side of the Y anyways. So as long as it's on one side of the Y, I run my math, which should put it on the other side of the Y, which will get added only if it hasn't already been added by the other one on the other side. So that's fine. So make sure it only gets added once. That's it. And then we just get the length of this thing, this accumulator that I created, which then gets saved as post photo. I just see how many there are in there.
Looks very similar to Farouk's.
Oh,
Yeah, in the math part, like I couldn't remember why I had that larger. Why you have a if comparison there? Now it hit me after explaining. Yeah, because they had to be at the bottom, like they had to be larger than the line to be moved to the upper.
yeah, it depends on the way you look at where 0, 0 is. But yeah, because some people like, I know some people start 0, 0 at the upper left, and also people who start 0, 0 at the bottom left.
That's weird.
But bottom left is the way it normally should be, because X's
Yeah.
and Y's on a standard Cartesian graph, you know, it goes to the right and up, not to the right and down. But it doesn't really matter as long as you're consistent in this case.
Arrays is always going to be 0, 0 on the top left. So.
Yeah.
But yeah, different ways of thinking.
Yeah.
I'm wondering how you approached part 2.
Well, for me, part 2, because like you, Farouk, you know, I created code where I read everything and I created both axes. Didn't really have to do much.
Should we review the question for part 2? I don't think we talked about it yet.
Oh, yeah, sorry. So part 2's question was, now that we've done everything, do all the folds, right? And then see what you get out of it. So you do all the folds, and then you have to somehow, and it's, you know, it says what, since, you know, you're looking for 8 capital letters and all you have is a bunch of coordinates, you have to make that mental, I guess, association that, oh, maybe these points contribute to letters. And then so you print them out and hopefully you get letters out of them. But yeah, so for my code, everything is pretty much the same. The only things that changes is that I don't just use 1 and 0. I use all of them in terms of all the folds. So I iterate through all the folds. And then after I iterate through all the folds, then I, let's see. Oh, I just try to get that max X and the max Y to kind of get an idea of what I'm going to do. Is I'm just going to scan these like a printer, and I'm going to, at some points along the way, have to, you know, either spit out a hash or a space. But I need to know how far this, you know, printer needs to go, like how many characters sideways and how many rows it needs to print. So I need to get the max X and the max Y. So I guess if you go along with Scott's idea of everything goes in half and half and half and half and half, I guess you can kind of predict how large it's going to be. But I didn't make that association, so I had to make sure I looked at the
I did the same for my
calculated
part 1
axes.
even. When I was creating my paper, I got the max X and max Y initially.
Oh, that's true. Yeah.
I already did that for part 1. But
Yeah. And so, well, for the max X and max Y, depending on how you fold it, it may be smaller, right?
Yeah.
If you fold it down, for example. Anyway.
Yeah,
for the final max X and final,
Yeah.
final X and Y's.
So I get the max X and the max Y, and then I just scan through like a printer, like I said, left to right. And then before I figure out what to draw for each dot, like a scanner as it scans through, I just see if it's included in the post folds. In this case, it's a vector. And if it's in the vector, then I print out a hash. And if it's not in the vector, I print out a space. So it's like a printer, it just keeps going on and printing.
All right.
Right.
Yeah.
Nice approach.
That's mine. Any questions?
Looks good.
Yeah, looks good. Okay.
Farouk?
Yeah. Okay, I'll go. So add the code. So I also updated my one until all instructions. And after so basically I already have my coordinates, my ending coordinates, right? And based on part 2, those coordinates, either on a small piece of paper or a large piece of paper, they have to constitute a range of letters, my coordinates. I could draw them, but I decided to approach them online. So I got my coordinates just like this. It's for my sample input, but for my input too. So this is the coordinates that I'm ending up with at the end of the execution, right? On a small piece of paper or big one. So I decided to take those coordinates and run them through graph drawing tool. So can you guys see this?
Yeah!
So I pasted all my coordinates in my resulting end, and I got this one, beautiful letters.
Upside down.
So if you can see, I have H, I have K, I have U here.
It's all upside down.
Yeah, it's upside down. I have J, it's also upside down, and I have G.
Upside down
A.
and backwards, right?
Some of them are like H and K, I think it's not upside down, right? H and K is fine.
It's still upside down.
But the rest of them, I didn't understand why. But so I decided to approach.
Clever man. This guy.
Basically, H, K, U, J, G, A, G, and Z.
So you got your coordinates and you're just like, it's good enough, I'm done.
But the rest is just visualization, right? So,
I like it. Hey, it works.
so that was, I liked it. I enjoyed it somehow.
Yeah, I like this one where you can't just get the computer to like spit out the answer for you. You got to visualize it and actually read the answer.
Yeah.
Can I share mine? So mine, since I already created my like paper grid for part 1, I was pretty much done. The only thing I had to do now is, whereas for part 1, I had my loop that was looping 1 time pointlessly. Now for part 2, it's time for that loop to shine. So now I can actually loop through the entire length of my folds array. And so, yeah, I did the same thing, exactly the same thing, except I was able to cut out code here because now I no longer need to care about how many dots there are. I just want to print them out. So now instead of logging the number of dots, I'm going to console log my paper. Okay. And then I took that, my grid, my paper, and put it into a text file here and formatted it a little bit to look like this.
Oh.
So we can read here. It's actually, if you guys can see the top right corner, can you guys see the top right corner of my file where it shows like the little preview? It's actually easier to read there, where you can clearly see HGAJBEHC.
That seems like a watermark.
Yeah. Anyways, that's what it looks like.
Oh, but nice. I want to see how you guys draw this because I tried to draw it in my terminal. I tried to input it honestly, but I couldn't read.
Oh, yeah. If I actually run it. Let's see, what was this?
It was outputting something, the coordinates probably, but I couldn't put it together.
Oh, where'd my terminal go? It disappeared. There we go. Let's see. I'm on day 16 right now. We want to go back to 13, right? Yeah, so if I console log it, can you see my terminal? It's gonna look like this. So I had to take this and just format it in the text file, just to get rid of all the junk. With a lot of just global search and replace.
Mhm.
Yeah, and make sure to get everything up onto the same line. But yeah, ends up just looking like this. And I like the little preview thing here where it's actually easier to read. When it's big, it's kind of hard to see.
You're on mute, Alex.
Interesting how they came up with the input data here, like,
Yeah, I wonder how he created this question. It's cool.
right? Really, really interesting. Right? We are folding it multiple number of times, and we are ending up with letters in a graph.
Yeah. Yeah, I like this one. I seem to remember something from 2020 that was similar to this too. Like, I don't fully remember that. I think there was something like this where you end up with like an actual readout of a code like this. But it was, yeah, cool question.
Yeah.
You're on mute, Alex.
Alex, you're muted.
Continue.
Alex, you're on mute.
Sorry about that.
Okay. I think you said quite a few things that we didn't hear.
Oh, and I just said, since you guys are all showing off yours, I guess I'll run mine too.
Oh, yeah, let's see it. Yours probably looks
So
nice.
15B, takes a second because it compiles and runs it. Oh, wait a second.
Score.
That's not right. It's not supposed to be 15. What?
Oh, no, this is 13B. 13B.
Oh, whoops.
13.
That's my answer for 15B.
I like it.
Yeah.
But for 13B,
Ran in less than 10 minutes. Like, wow, yours prints out so clean.
Sweet.
Nice.
Yeah, I like how clean yours prints out. That's nice.
And also upside down.
yeah, somewhere on yours, I think when you did the folding, you folded up instead of folding down.
Me?
Yeah, or you folded down instead of folding up is I think how you
Maybe.
got yours reversed.
Some of the letters took me a while to realize, like I turned my laptop on and I'm like, hey. Then I realized, oh, it's upside down.
Yeah. Well, this is a fun one.
Yeah, pretty good.
But you got yours really clean.
Yeah, 'cause I removed all the standard formatting. I mean, otherwise, here, I'll go back and I'll show you a little bit of me suffering through code. Let's see, share screen. Which one is it? 13B.
Apparently, you didn't even need it. You could have just gone to an online tool to graph it.
Oh, yeah, the Farouk approach, right?
I like it.
All right, so for 13B, so if I were to just print them out, this would be, I guess it wouldn't be, to get it to print out, for example, the way that you guys had seen it, the way that I was able to kind of clean it up is I use just standard print instead of printing out the structure itself. If I print out the structure itself,
Okay.
then I just end up with a bunch of points. If I take each of the points and let's say, oh, because it's a vector of a vector, and then if I take each one of these vectors, let's see, post itself, post fold, let's see what kind of structure post fold. Post fold was made by input coordinates. Input coordinates is a vector of a vector. So I think to print it out like what you guys had done, I would have to take the post fold, iterate through it, and then I can just do it for each on each one of those, so that for each, let's say, line is what's coming in. I'm also going to iterate so that for each one of those lines. So this is now a point. Oh, I don't want to do a point. I just want to print out the entire line. So this will produce something like what Scott had before. So I can do a print line here. It's going to be a
Probably
new
clean
line
my box too.
afterwards. And the print line itself, in order to print out vectors, I need to do it this way, and I can print out each line. So let's save that. Open up a terminal. I don't know if actually this will work in a terminal. Maybe it will. I don't use terminals here, but at least I don't have to shift my screen over. So let's see if this works or not. Set my environment. Oh, okay. Oh, but this is running PowerShell. Yeah, I don't think this is gonna work. Maybe I have to do it the old school way. Do I have Rust C from here? No, I don't.
I could have made mine nicer by just joining all of my subarrays.
Essentially, that's the thing that I was doing. I was getting rid of the default formatting,
Yeah.
because otherwise, if I just use the default regular formatting, I'll end up with something kind of like whoops, what you had. That doesn't make any sense, because those are just all the regular points, right? 13b, those are all the regular points.
We can use the online tool now.
Yeah. For each line, I'm printing out the line, but the post fold.
Oh, I know what I can do for mine. I can just replace my dots with a space, and now it should be beautiful.
You should do a join on each line. You should do a join on each
Yeah.
line, and then for each of your, well, because you'll have to do a printing on each line with join the outer array with new lines.
Let me share. I was able to
Join all
get
the inner arrays with nothing.
Let me share. I'll show you what I was able to get. I was able to get it to look like this.
There you go.
Yeah, so it's quite easy, really. All I had to do is up here, I was previously adding in dots. So if I just remove the dot with use a space instead, and then where I do my console log down at the bottom, I just map through each row and join them. That's all it took to be able to get, yeah, a much prettier printout that I don't need to copy into a text file to read. All right. Yeah, that's quite easy to read now. Cool. That was a fun question.
Yeah, I like the tool too.
Well, we'll call it here. It's been about an hour and a half almost. So we'll move 14 and 15 to tomorrow or to Friday. And
Right.
go from there. I think I need to finish up 15 then before Friday.
Are we going to have time for a video on Friday since we have the student's graduation?
Oh, that's true. Okay.
So
But
might wait till next month.
We'll figure out the timing, but something hopefully on Friday. If not, then not the worst, we can just push it to Monday.
Yeah, I think the graduation starts at 1 o'clock on Friday. So if we want to do a video, it should be either before, I don't know, either start like 11 or 11:30 or start after 3.
Sounds good. Well, for the purpose of the video, I think that's it for today. And we'll catch you guys again on Friday.
Yeah, next time, I guess we'll do 14 and 15 next time.
Yep.
All right. Take care, everyone.
Bye-bye.
Hey guys.